without my buddy Manish. He couldn't be here. However, he did ask me to speak today to HOCON files, specifically adapter configuration, and doing that configuration in a HOCON file, and then how to encrypt values within an adapter configuration. So for instance, if you were connecting to some external source and you had to provide a user and password pair, how we can protect that password pair by not letting it be humanly readable. So I think the best way to do that is to show a series of examples. Any given one of our adapters is configured a little differently. So I'm going to show you some of those different options for configuring adapters, and then we'll talk about the HOCON files. And within the HOCON files, there are multiple options. And then we'll talk about how to actually do the encryption within that HOCON file. So let me share my screen and we'll get started. Okay, so the easiest thing to do often is to use one of our shipped samples. And so from the file menu, if you choose import samples, and we're going to start with OSI Pi. And so if I just start to type OSI, we see we have this choice. We ship this sample, say import now. It brings it in and starts you on the README. I'm not going to look at the README. I'm going to take you guys to the code. Here is the event flow, and any one of these adapters, let me resize my windows here. If I click on the OSI Pi adapter, we see this properties page. Underneath the stream-based properties, we see that we configure the adapter right here. And in particular, on the server tab, there are some variables. Now, these variables in this particular sample are coming from the parameters tab up here. Many of them are null strings right now. There's no value set, so you would enter your username and password pair right there. And this poses its whole own set of problems for how do you externalize that data and how do you protect that data. But we'll come back to that in a minute. So the point here is that this particular adapter is configured via the property pane. Okay, so let's load a different sample. We'll kind of compare and contrast. And this time we're going to look at MQTT. And if we pull in the MQTT sample and dismiss its README, we open up MQTT and we look at its SB app and we set the focus on the MQTT adapter. We see some configuration details here in an edit button. And if we click on this edit button, we're brought to an mqtt.conf, a configuration file, a HOCON file. And we can kind of scroll through here and see all the different details that are available to us to be able to, all the values we can set to pass through to MQTT when we do our connection. And that HOCON file is in the project under source main configurations. So we see it over here. So we could either open it up from the Project Explorer, right? We could say open, or we could access it off of this edit button here on the properties page. And let's look at one more, let's pull in one more sample for our comparison. And our own EMS, TIBCO EMS adapter. Dismiss the README. We'll go take a look at its event flow. And I will note this guy does not compile out of the box. It needs third-party libraries to be installed. It needs to have its those third-party libraries installed in the Maven repo and or point to where they're installed in the Maven repo for it to be able to compile. So out of the box, this guy does not compile. It has type check errors, but we can still look at it. So if we put our focus on the EMS, any one of these EMS adapters, whether it's the producer, the consumer, or connect, we also see in the property pane an edit button. If we click on this edit button, we are brought to a form editor. So if you notice on the tab of the form editor, we actually have a named configuration file, jmsadapter.conf. And if, again, we look over here in the Project Explorer for this particular sample under source main configurations, we see that adapter.conf file. Now, we've built this additional form editor kind of quote unquote in front of the HOCON file, so you're not dealing directly with the XML within HOCON. You could dismiss that form editor, and you could, inside of the Project Explorer, say open with a generic text editor, and then have access directly to the traditional XML in this file. I don't suggest you do that. It's way easier to use this form editor. I simply show it as an example that there are at least 3 different ways to configure adapters in Streambase. And so when you drop an adapter onto your canvas and start to use it, you'll quickly find out which one of the 3 ways that particular adapter uses. Okay, so let's go back to the first example, OSI Pi, and let's talk about if we wanted to take these values, this username and password, and make them available, expose them outside of Studio, how would we do that? So the way we do that is with a HOCON file. You can, if your adapter like MQTT provides a HOCON file, great. But when it doesn't, you can create one. So I can create a HOCON file. Let's go into the OSI Pi sample, and I can say new HOCON configuration file. And I have to give my HOCON a name, Pi params. And there are basically 3 different ways you can pass parameters. You can have operator parameters. This is an older deprecated way of doing things. You can have container parameters, or you can have module parameters. So if I search for the word container in all the various HOCONs, it narrows it down for me. There's exactly 1 type of a HOCON file that has container parameter settings in it. So I am going to check this little checkbox at the bottom that says generate all my sample values and press finish. And I have this HOCON file in front of me now where almost everything is commented out. So if you don't know a lot about containers, what you need to know is that there's always 1 default container. And so we can come in here and we can name the default container, and we can set parameters that would apply to that container. At a somewhat lower scope, also in this file, we have the ability to name a module, and within that module, you can set parameters. And so then those parameters would be available only to that specific module. So this is how we recommend you do things, to use the SB engine file and use either container parameters. Okay, so again, in the container section, container parameters, or in the same file, you could set your module name and then set your parameters here. And then there is the old way. If you're using older code, you might be using an operator parameter. Okay, I have an example of the old deprecated operator parameters in this little project that I've created. So instead of talking about adapters now, we're going to just talk about a real simple event flow. It's the same construct. You use the HOCONs the same way, but this way we can just narrow it right down. And no matter which of the configuration file options you use, whether you use container parameters or module parameters or the operator parameters, they all behave the same way. So if we take a look at the configuration file in this more simple project, we see it is also of type SB engine, and it is using this directive. And if we hover over the warning sign here, we see that it says operator parameters is a deprecated property. This property has been deprecated as of version 10.5 and replaced with the use of container scope or module scope parameters. And that's the other two options that I just showed you. So regardless of which one of those three options you're using, maybe you have some legacy code that's using this deprecated method, or maybe you're using one of the two newer supported methods, the format is always the same inside of the HOCON. You have a value for you have your variable, and then you have the value for that variable. And so in this case, my operator is going to have a user named Fred, and Fred has a password of the number 123. So using this simple little example, now we're going to talk about how can we protect that password so that people can't come into this code, open it up, and find out Fred's password. Okay, so how do we do that? We use the epadmin command. From this project where I want to encrypt my values, I'm going to open a stream-based command prompt. And using that stream-based command prompt, I'm going to issue the epadmin command to first create a key store. And then using the key store, I'm going to encrypt the value. It's a two-step process. So if you already have a key store, then you only create the key store once, and then you can reuse it to encrypt as many values as you want. So the format of the command is epadmin create secret, and then you pass a directive that says where to place the key store that's being created, and what will that key store use as its password. So we run that command, and we get back a little message that the master secret has been generated and stored in this file in the local directory called my key store. And now that we have a key store, we can use that key store, run another epadmin command, epadmin encrypt, to encrypt our data. And the encrypt command takes that key store that we just created, its password, and then the data that you want encrypted. So I'll remind you back here, Fred's password is 123. So we're passing the string 123 to be encrypted. And when we run that command, it returns to us a string that starts with a hash and then a double bang. It is this string that then we take and we put into the HOCON file, regardless of which style HOCON, regardless of which style parameter you were using, we put that string in place of what had been our human readable password. And it's that simple. You save that, and now your file that is going to do the connectivity, that's going to be used to get the credentials to do the connectivity to whatever source you have that requires credentials, the connectivity is obscured, right? The password is no longer humanly readable. Now, there's a couple of additional tips that I want to give you here, which is that if you want to run inside of Studio this project, the project needs access to that key store file. The way we do that is through a run configuration. So here's our application, here's our event flow fragment named Fred. It's a very unique name. And on the node, we need to have these two entries here. And the two entries say, what is the name of my key store? Where is it? And this path must be an absolute path. And then what is the key store password? And so this is required within Studio so that as Studio runs, it can go contact that key store and do the decryption and then bring you back the value, the decrypted value, and then use it inside of your event flow inside of Studio. If you were running on the command line, if you stood up your node, if you said epadmin install node, then one of the directives to install the node is to provide the key store so that encrypted strings in that node can be decrypted. And you have the option of whether to prompt for the passwords at that install time or not. So you don't have those options when you're running inside of Studio. And another thing that I'll show is that as of today, as of this recording, when you want to run something with encrypted passwords inside of Studio, you really need to run it as an application instead of running it as an event flow fragment. So this won't always be true, but it's true today. So how do we accomplish that goal? First, we create the application. So we say File, New, Stream-Based Project. This project's name is Fred, and I'm going to create an application. Instead of an event flow fragment, I'm going to create an application. I choose Stream-Based Application. I say next, next, finish. Okay. Or you could have just hit finish. You didn't have to say next, next. So now, using my Project Explorer, I'm gonna shut down Fred there. I'm gonna shut down our OSI Pi, and I'm gonna look at this application. I'm gonna open its palm and click on the Dependencies tab. So by default, I just created the framework of the application. I don't have any dependencies in there. So I'm gonna add one, and what I'm gonna add is the actual event flow fragment that is Fred. So I'm taking Fred as an event flow fragment and I'm creating its application. And it's that simple. If I had other fragments that were going to work together, other modules, I could add them in here. If I had third-party library dependencies, I could add them in here, but I don't have any of those. I just have this simple Fred event flow module that I want to run, and I need to run it as an application in order to have access to the key store. Okay, so now that we created the framework that will be our application, we need to actually build the application. And so right-click on the Fred app, let's say Stream-Based, create Stream-Based Application Archive. This big dialog is open, and basically we're going to push this button over here, Package Application. It's taking all the dependencies. In our case, there's just one little event flow fragment, and it's putting them together. If you watch the output up here, it's building all of the fragments, and we get build success. It built Fred.event flow fragment, and now it's taking all the event flow fragments and putting them together in the larger structure of the application, and we get another build success. So now we have our physical application. That application needs a run configuration to be able to decode this encrypted string. So from the Fred app, we can say run as and choose run configurations, or you can come up here to the run menu and say run configurations. And we look and we see underneath the stream-based application, there's something called new configuration. We really give that a much better name, the Fred app run conf. And what application archive do we want to run? We can choose the browse button, and then it shows us here's the only application archive we have in our workspace right now. If you had more than one, you'd have to pick the right one. So now we're going to try to run that application archive, that zip file, and the code that's in that zip file. And on the node tab, we need to do the same thing that we did for our event flow fragment. I'll just remind everybody that that needs to be an absolute path, and it needs to have forward slashes, not backward slashes. So I'll fix up the slashes, and then we'll save this guy, and we can run it, and we'll see that we can run this application inside of the Studio, and we'll have access to the string that is the password. So yes, go ahead and switch perspective. Okay, so this application just started up. what our simple application is doing is we're going to send a tuple in. We're going to, in this map, access this variable, which is in our HOCON file, and it's an encrypted value. And then we're just going to print it out. So what we hope to see is that because we provided the key store, we can, when we access this variable, it will translate or decrypt the string and then let us have the non-encrypted string for our event flow. This isn't a great amount of event flow, but it'll prove the point. So if we come back into the test debug perspective and we send a tuple in here, that makes this event flow go, and we execute the map operator and then the output stream, and sure enough, we see that our password is printed out to us and we've decrypted it and we've said your password is 123. So this is how you protect your strings inside of an event flow application, specifically at your points of connectivity. Within the adapter itself, or in this case, within an operator, you use a HOCON file, and inside of the HOCON file, your HOCON files live in source main configuration, and inside of your HOCON file, you can, anytime you want to, you need a password, you can put plain text there if you want, or you can put encrypted text. And once you put the encrypted text there, then no one can just, like surf your project on your file system and know what your passwords are. There are additional levels of security. Namely, if you were running this outside of Studio, if you stood your node up, as I showed you, once you're inside of that running event flow, your passwords would be decrypted. So maybe you also want to apply a security realm and secure the perimeter of your node or of your streaming cluster so that no one could try to come in and, for instance, DQ a value and see the human readable form and therefore steal your password. But at the very first level, we secure at the point of connectivity, and the way you do that is inside of a HOCON file. And if your adapter doesn't use a HOCON file, it doesn't come with a HOCON file, you can create your own. It's of type stream-based engine, and then within that type stream-based engine, you have three options: the old deprecated option of an operator parameter, or the newer options of container parameters or module parameters. So I hope you found this helpful. And I hope that our next session will have my buddy Manish back with us. Okay, thanks. See you next time.